Righto, welcome back. We're going to look at Pythagoras' theorem. Great story to start off with before we get into Pythagoras' theorem. Pythagoras was an ancient Greek guy. He was a Greek nobleman, and he lived at a time in Greece, really interesting times, when there was a real divide. I mean, if you think there's a separation now between classes in our society, you ain't seen nothing. Back in ancient Greece, there was a divide between the nobility and the slave class, or the peasant class, or what we call the working class now, such that it was actually illegal. It was against the law for people who weren't a part of society, weren't part of the nobility, to learn, to go to school, to get an education. Now, when you tell that story to a lot of sort of younger high school kids, they're like, "Oh, I wish it was illegal to learn maths now." It was illegal in Pythagoras' days, but he wanted to teach. He was a teacher at heart. He wanted to teach people. He wanted to share some of the ideas that he was coming up with. There's a big danger when you are doing that, though, because he necessarily had to hide the fact that he was running a school. He couldn't make it public. And you run into very, very big dangers when you have an idea that you don't put out there for criticism. Because if I come up with an idea that's right, well, good for me. But if I come up with an idea that's wrong and I can't see what's wrong with it, and I don't put it out there for criticism, or I don't let people criticise it, well, then what can happen is wrong ideas sort of tend to have bad consequences, like right ideas have good consequences, right? So there was a couple of ideas in Pythagoras' school that were very wrong. A couple that were very good, a couple that were very wrong. One of the ideas that Pythagoras had, and a lot of sort of nerdy mathematicians who don't know any better often get this on a coffee mug. Pythagoras, one of his famous quotes is that all is number. Everything comes down to numbers. He had this idea that whatever God made the universe, that God was a mathematician, okay, and that he used mathematics to make the universe. Because when he looked around the universe, he saw that everything can be counted or measured or weighed, and so everything was basically reducible to numbers, or so he thought, right? And so he thought, well, any intelligent being that made a universe that's basically reducible to numbers must himself be a mathematician. And so that, hence, everything is number. If we learn mathematics, we can become like God. Bad idea, right? There's a long history of ideas that say if we do this, we can become like God, going badly for people. So that was one idea that he had, right? The second idea he had was he thought that numbers existed. Now you're probably sitting there thinking, well, Mr. Obeid, I think numbers exist too. Right? Well, they don't. Okay, let me show you why. If I said to you, show me 3, right? You might say, well, 3, there you go. I said, well, that's 3 fingers. Show me 3. You might put 3 dots down. Well, that's 3 dots. Right? Or 3 sticks. Well, that's 3 sticks. Or you might write the numeral 3. Well, that's a numeral that represents 3, but show me 3 itself. Well, you can't, because 3 itself is actually an abstraction that's only in our mind. It doesn't actually exist. It doesn't actually have an existence of its own. Okay. So if 3 doesn't exist, well, then no number exists, right? Numbers don't exist. They're abstractions in our mind that come from realities that we see around us. Okay, but Pythagoras thought that numbers existed, that they had an existence of their own. Okay, so that was his second wrong idea. 1, God was a mathematician, and if you learn maths, you can become divine. 2, that numbers existed. And then the Greeks used a manner of speaking about numbers that we still use today. Okay, so they spoke about how numbers, every number can be written as one number over another. Okay, so the number 3 can be written as 3 over 1, or a quarter is 1 over 4. you know, or 2/5 is 2 over 5, you know. So every number they thought this is reasonable, it makes sense, it's rational. We call those numbers today rational numbers. And if somebody's thinking clearly, we say, that person is rational, you know. If somebody's thinking not clearly or illogically, we say, that person is irrational. That doesn't make sense, right? Then Pythagoras came along and discovered his theorem. And as we're going to see, Pythagoras' theorem involves the idea of surds. And some of the surds were fantastic, right? Square numbers, square numbers, square numbers. You get a square root of a square number. It's a whole number. You get the square root of other numbers, they end up being rational numbers. No problem at all. But then they come up with these numbers like the square root of 2, or the square root of 3, or the square root of 5. And they couldn't work out how to express these numbers as rational numbers. And they said these numbers are irrational. They don't make any sense. Right? So, irrational numbers. Now, God was a mathematician who made the universe. Right? Everything was number. Numbers existed. They had another wrong idea. Let me explain that one too. They also believed not only that numbers existed, but the numbers came into existence. So there was a time when a number didn't exist, and then when you worked it out, well, that's when that number was born, so to speak. So let's pretend that nobody had ever counted past the number 20, right? Just for argument's sake, right? Yeah, they had bigger numbers than 20. I'm just doing this to illustrate a point. So let's say nobody had ever done anything over the number 20, you know. So they only asked themselves multiplication problems like what's 3 times 4, or addition problems like what's 10 plus 7, or things like that. Well, if I come along to you and I say, hey, listen, what's 19 plus 2? And you go, whoa, that'd be 21. Wow. Well, it was at that point in time that the number 21 came into existence, right? That actually became an existing thing. Number 21 now, it didn't exist before, and now it does. Pythagoras' theorem brought into existence, or so they thought, irrational numbers. Root 2, root 3, root 5, etc. Okay. Well, they thought that the only way that a universe that's so perfectly ordered and so rational can suddenly have these irrational numbers coming into existence is if the rational God that made the universe has abandoned the universe. And that means it's the end. And so in a panic, the Pythagorean school became a suicide sect. They all killed themselves. Okay, we only know about Pythagoras and his school basically from archaeology. There was no lived-on, handed-on tradition. It's not like Pythagoras taught somebody who taught somebody who taught somebody who taught me who taught you. Okay, they all died, and then people discovered the bodies and thought, what on earth happened here? And then they examined their writings and then found out what went wrong. Okay, so some very, very dumb ideas in Pythagoras' past. But one of the good ideas, like I said, sometimes you come across a bad idea and it has bad consequences. You have good ideas, and the good idea has great consequences, like Pythagoras' theorem. Here's a right angle triangle. Pythagoras showed us that a squared was equal to b squared plus c squared. I'm not going to go through a proof. There's more than 80 registered proofs, different proofs out there for it. If anybody is really keen to see one, look one up, or I'll be happy to go through one for you. Just let me know. If I want to find the hypotenuse, here's the version of Pythagoras' theorem I want to use. If I want to find a short side, here's the version of Pythagoras' theorem I want to use. You've seen this before, but let me show you with these examples. Look at this problem down here. I'm looking to find a short side. Well, short side, I use this version of the formula. So over here, x is going to be the square root of 13 squared minus 12 squared. So our a is our hypotenuse, our longer side squared. You'll know if you get this wrong because you'll end up with a negative under the square root sign. Then you've got these in the wrong order. Okay. So we go away, punch them into our calculator. 169 minus 144 is 25. Square root of 25 is 5 units. Okay. And you can check that on your calculator. What about over here? Well, over here we're looking to find a hypotenuse. We're going to use this version. So x is the square root of 11 squared plus 5 squared. You get them in any order, it doesn't really matter. Now that's not going to work out to a nice number for us, so we'll go to our calculator for that. Incidentally, not sure if you can see that, got a new calculator, very fancy. Oop, focus, please focus. Nope, doesn't want to, there it is. Very fancy. You're not allowed that in the HSC. Sorry, I'm just showing it off. So we've got 11 squared plus 5 squared under our square root sign. That's the square root of 146 as an exact answer, which would be 12.1 to 1 decimal place. So 12.1 units to 1 decimal place. Now, as a general rule, we like exact answers in our course. We do use decimals, but we always make sure we say when we're rounding off. So if it's a measurement, you can use a decimal, but you make sure you point out, you show the real, the exact value that it came from, and the rounding off that you did. Okay, that's Pythagoras Theorem, guys. That's the beginning of our first exercise in trigonometry. I'll come back with a revision of the trig ratios coming right up.